Here is the first example. In this example, we're going to find the transfer function for the given electrical circuit. Okay, so what is transfer function? As I always mention, so if you have a system, so in this case, instead of system, you have a circuit. Okay, so here is your input V of t and output is VL of t. Okay, the transfer function is nothing but VL of t over V of t. This is nothing but H of t. That's a transfer function. That's what he's asking for. But probably in this example, we're going to do it. We're going to find it in S domain instead of time domain. Okay, so first thing we need to do, we need to convert the time dependent quantities into S domain. Okay, what are the time dependent quantities? Inductor is a time dependent parameter, or it's a time dependent element. Resistor is a time independent element. So inductor or capacitor, both of them are time dependent elements. So we need to convert them into S domain. Behavior of resistor is same both in time domain or S domain, so we don't need to convert that. So here I'm going to take this. When we convert this into S domain, this is basically 1S. Okay, that's 1S. That's 1S. Okay, resistor is going to be the same. Okay, now our goal is we need to have a relation between the input voltage. I'm going to take this as V input and I'm going to take this as V output, VS. Okay, so whenever we transfer that into S domain, you see, the quantities, we're going to represent them in capital letters instead of small letters. Okay, you can use mesh analysis, nodal analysis, however you wanted. Here, what I'm going to do, since I need to find the voltage, I'm going to use the nodal analysis. Okay, so I have, if I'm using nodal analysis, find out how many nodes are there in the circuit. A node is nothing but where two or more elements connected. So basically this is one node, node 1, node 2, node 3, and node 4. All these three elements, this element, this element, this element. So 1 Henry inductor, 1 Henry inductor, and source. All three of them connected together at this. So that's fourth node. We always take one node as a reference node, and we will take that reference node voltage 0 volts. So the voltage at that point is 0. Now at node 1, the voltage at that point must be Vn, because if you look at the source, here is the source, this is V reference, that value is 0. I'm taking this value, say for example, I'm going to take that as VA, and here is Vn. Okay, we know that VA minus 0 must be equal to Vn. Okay, based on this principle, I can tell the voltage at that point is Vn. Okay, I'm not representing, let me take this as VA. Okay, VA equal to Vn. Now the voltage at this point is Vs. Okay, and let me take this as Vb. Okay, now to find out voltage at Vs, you need to apply KCL at Vs and at Vb. So I'm going to do apply KCL at Vs. I'm applying KCL at Vs. I'm taking every current is going out. So I'm taking I1, I2, and I3. All three currents are going out of the node. So I1 plus I2 plus I3 equal to 0. Now what is I1 here? I1 is nothing but Vs minus Vb over 1 plus I2 Vs over 1s plus I3 Vs minus Vn over 1s equal to 0. So to eliminate the denominator, I'm going to multiply this with 1s. So s times Vs minus Vb plus Vs plus Vs minus Vn equal to 0. So once I simplify this, okay, after simplifying the circuit, the equation, I end up with 2 plus s times Vs, because Vs plus Vs, which is 2 Vs plus s times Vs, so it's going to be 2 plus s Vs. And I have Vn, take it to the other side, and s times Vb, take it to that side. So all I need to do is replace this Vb with either Vn or Vs to find out my transfer function. Now at Vb, apply KCL. At Vb, apply KCL. Here also I'm taking every current is going out of the node. So it's up to you. You can choose in different way, but I preferred it in this way. So IA plus IB plus IC equal to 0. IA plus IB plus IC equal to 0. What is my IA? IA is nothing but VB minus VA over 1. So VB minus Vn over 1 plus IB is VB over 1s plus IC is VB minus Vs over 1 equal to 0. Now I'm going to multiply this with s, so it's going to be s times Vb minus Vn plus Vb plus s times Vb minus s times Vn, or s times Vs equal to 0. Now I just wanted to simplify this. So here applied KCL at Vb. As I said, I'm taking every current is going out, IA plus IB plus IC equal to 0. So IA here is nothing but Vb minus Va over 1, and IB is nothing but Vb minus 0 over 1s. IC is nothing but Vb minus Vs over 1s. Okay, so that's what I have here. To eliminate the denominator, I multiplied that with s. Once I multiplied with at s, I end up with Vb equal to s over 2s plus 1 Vs plus Vn. Now as I substituted this Vb in the given equation, or in the equation 1. So this is my equation 1. So I got this equation 1 by applying KCL at Vs. Okay, this equation 2, I got it applying KCL at Vb. Now I substituted Vb in equation 1. I ended up with the relation Vs over Vn equal to s square plus 2s plus 1 over s square plus 5s plus 2. This is the transfer function for the given circuit. I'm going to solve a few more examples finding transfer function for the given electrical circuit. Thank you.